Hello everyone, good afternoon wherever you are. Welcome to yet another fifth for the series. We had several other hands-on sessions. We had like four, so this will be the fifth one. It promises to be interesting. Like you already shared the details of today's session. It's minimum on data engineering track, but data scientists will also benefit and every other person. So thank you everyone for joining. Thank you, David. David is here, everyone. Mr. Ahmed. You guys are very welcome. So before we start proper and still waiting for others to join, I'll just give a few brief instructions or information. So this session will last, take an hour, 15 minutes or an hour, 20 minutes max. So towards the end of the session, we'll have time to ask your questions and whatnot. Also, coming up on Friday, we'll have another hands-on coding session for the data scientist track. Now we'll be talking more on neural networks, Tensorflow, computer vision. So just keep that tab also on your calendar. Okay, without wasting much of our time, let's just go straight to what we have today. Today we'll be having a guest taking us for this session. His name is Ohakim Emeka. He's a data scientist at Hamley AI Labs. So we'll be the one taking us on this session. So sit back and enjoy and try to follow along. If you can't follow along completely, as usual, this video is always on our YouTube channel. Just search and see it. Okay, without wasting time, I welcome him now. Mr. Emeka, you have the floor.
All right. Can you hear me? Good afternoon, everyone.
Yeah, can
Good day,
you
everyone, from wherever you are. My name is Emeka, and I'm a junior data scientist at Hamley AI Labs. I'm here to show you how to deploy ML models on Tensorflow 7 and Kserve, and also deploying those services on kubernetes. So I'm going to share my screen now. Yeah, so hope my screen is visible. Yeah, so I have already shared, like, I have a GitHub repo with all the code we're going to use for today. So it's going to be like, hopefully it's going to be interactive, like, so let me get to it. So what is TF7? I know TensorFlow 7. So I'm going to like check their documentation, and I'm also going to explain. So TF7 is like is a component of TensorFlow, is a part of their package, their full-on package, TensorFlow 7. So what is used for is like it's used to deploy algorithms, their models, like, so like you can actually access the models from online. So it's part of the TensorFlow stack. Yeah, so I know my colleague in the previous hands-on lab, he showed you how to deploy a model with Flask and deployed it on Kubernetes, right? So, but in this one, this TensorFlow 7 is like a more efficient way. It's a high performance way of serving machine learning models. Basically, TensorFlow models. You get. So let me get hands on with it. So in this session, I am um in this session I am hoping that you have, or we require, the use of kind is like in the material that you are given on the data engineering track. They asked you to install minikube. Yeah, minikube is requirement, but kind is also the same thing as minikube. It helps you host or control Kubernetes cluster in your local machine. Get. So, but kind is the same thing. So any command I run here can also be run on minikube. Get. But I will tell you as we go why we're using kind keeps it here. I hope basically because you did I hope you attended the previous session, so you know what keeps it here is. It's for interacting with your Kubernetes cluster. So let's get down. Let's get into it. So basically, I'm going to have some code that I've prepared. All right. So in this material, we are not perfect. Yeah. So yeah. So this code now, this script. What this script is for now is for me to train a simple MNIST model. So let me want to deploy a model on we want to deploy a model on TensorFlow 7 and it accepts TF, it's only TF7 accepts TensorFlow model basically. So right now I want to deploy this model. What it does, it classifies the MNIST dataset. You hope you guys know what the MNIST dataset is. The MNIST dataset is basically numbers from 0 to 9. So people went down and they wrote number 0 to 9. So a neural network can now guess or classify if that number is like it will classify the number, if you get what I mean. So in this data set, there are numbers 0, 1, 2, 3, 4 in black and white. So we're going to feed it into a neural network that can classify images and going to classify whether that image is number 0, number 1, number 2, number 3, number 4, number 2, number 9, right? So let me like carry you through the code. So we're going to import matplotlib, and here we see that from the TensorFlow Keras MNIST datasets library, we're going to import load data. These are the layers we're using. So we're loading the MNIST dataset. We are printing the shape of the dataset, X and Y. We are reshaping it because for you to feed images into the conv layer, it has to be in a 4x4 tensor. You will discuss this if you join the data science track, neural network lab. We'll talk about what all this means if you don't understand what it is. Yeah, basically, so we're normalizing it because if you want to feed data into a neural network, it has to be normalized, and we're getting the shape and the number of classes. So number of classes in this data set is 10. So 0, 1, 2, 3, 4, 5, up to 9. So there are 10 classes. And this is where we are building the model. And we are compiling it with this. Hopefully, this is not a data science track, so I will not explain everything in detail. So, and now, the most important thing here right now is after training the model, you save the model. So TensorFlow 7 requires you to have your model in a saved model format. Yet, so after you train your model, you have to save the model. So you save the model in a particular folder. Yet, so I've saved the model. So I'm not going to run this code now because it's going to take time. I don't have a GPU on this virtual machine, so it's going to take time. So I've already trained the model and I've saved the model. I just ran this script, basically ran this script, Python model.py. I ran it, trained, and it saved the model into this folder, image classifier. Okay, so now what I'm going to do now is create a Docker file because the TensorFlow 7, you build it with, can be used through Docker. Okay, let me just get into it. Hopefully you understand what Docker files are because in your material, you've been taught what Docker file, Docker images, Docker containers are, and how they can be used in Kubernetes. So let me just assume that. So the base image is TensorFlow 7, right? So this file is going to go to the Docker Hub and download this 7 module for us. And so we're now going to, this Docker file, it requires that you copy your saved model, right? Your saved model, the model you save, you copy it into the, okay, let me now give you a breakdown. You know that Docker containers are like computers on their own. They're like virtual machines on their own, right? So they have their own ports, have their own file system, things like that. So when we're building that Docker container, we need to copy the image, the save model from our own local machine into the Docker container. You get? So that's what we're going to do. So we're going to copy the image classifier to the model, then image classifier, .1 /1. All right, and it's supposed to be all right. Then we need to set an environment variable. Okay, so we're going to set an environment variable. So this Docker container, he wants to know where is this model going to, like, what's the name of the model? Because in this TensorFlow 7 container, then in this image, it can take in as many models as you want. So this, what this environment variable does is that it's okay. Let me value there. So what we're doing now is that we're telling this Docker image, this Docker image, that this is where the saved model is. You get? Since we have copied the image from our local to the Docker container, we're now telling it, okay, this is where your Docker image is. Get? So actually, key is model name. Yet, so that's the key. Model name is image classifier. So this is where it's going to search for that for that model. So right now, what we're going to do is we're going to build this image. Let me SSH to my virtual machine. Okay. So into labs, and I'm now going to run this command, docker build. It's going to build this Docker file into an image. It's going to build it and it's going to call that image, then TF7 classifier. And this is the tag version 01. And it's going to build it in this directory. So let me copy that. Okay, so it has successfully built the Docker image. So this is the name of the Docker image. Just successfully built it. So right now, what we're going to do now is we're going to run it. We're going to run this this Docker image, right? Let me copy the command and I'll show you what it does. So it's going to run this tag, this TF7 classifier image. It's going to run it interactively. This IT, it means interactively. That means we're going to see some outputs in the console, in the command line interface, and it's going to remove it after we are done with it. Yeah, so that's what this RN means. And this P/P tag means we are connecting our port 8501 on our local machine to port 8501 of the Docker container. All right. I said before that a Docker container is actually like a virtual machine on its own. So it's like a computer that is in your computer, if you get what I mean. So you need to like directly connect your ports, the port of your local machine into the port of the Docker container. You get that? So let's do that. So it's going to run it. It's saying the image classifier is not found. All right, let me see why it's saying that. Image classifier, right? Supposed to copy it. All right, let me go to the Docker file here. Because I've already prepared the code. Oh, sorry. it's supposed to be models. So these commands are really specific. They are really, really specific. Like you have to get it. So now we have to rebuild it. We're going to rebuild it. We're going to rebuild it, and we're not going to run it again. Yeah, so now let me explain something. So TensorFlow 7, it has two ways of deploying your model. There are two ways of deploying your model or accessing your model. There is the REST API format and there's the gRPC format. Yeah, so in the previous session, my colleague taught you how to deploy a model with Flask. So now Flask exposes your model in the server, and the way you communicate with Flask to get your model is through REST APIs and HTTP methods. You get so REST is like the normal protocol used in web application. You get so what is basically REST like? So your web browser now, you want to basically what your web browser does, like if you want to go to google.com, what it does is sends a GET request to your to Google's server. It sends a GET request to Google's server, and your Google server now replies with the home page of their web service, and your browser now renders it on your screen for you to get. So that's basic. That's REST API. REST API is common. There's the get, there's the post, there's the delete, there's put. That's the way to communicate with basically almost all the backend servers and everything. That's it. So, but this gRPC is a more complicated one. You get so gRPC is built by Google themselves. You get you're built by Google, and it's more efficient. It's in the REST format. You use JSON to send data. Like if you want to send your credentials or something, they send it through JSON. You get so now after in gRPC format, what they use is the protocol buffer. So it's a different format entirely. So it kind of encodes it, and what gRPC is more efficient in a way that it encodes your data, and it makes it smaller, and it's low latency. Low latency as in it's fast. If you send in your request, it will send in your reply like fast. That's what latency is. More latency, fast. So you send something and it replies you like faster. Yes. So that's like an overview of what REST and gRPC is. If you want to learn that, you have to take like a tutorial on that. And yeah, if some of you have tried deploying a model with Flask or Django or Fast API, you should be familiar with REST APIs and all this. But gRPC is more complicated. But in our use case, we're going to use REST API. So TensorFlow service exposes the REST API at port 8501. And remember that we forwarded our local port 8501 to the port in a container 8501. So we have to send requests through that port 8501. Yeah, all right. So let's make a prediction. So I'm going to create a file, call it predict.py. So I'm going to okay. I want to make a prediction with some data. So let me copy and paste some command from here. From Docker file. So I'm going to collect the test data. Remember that the model was trained on training data, and I want to make tests with the test data. So what I'm doing here is I'm just taking the X test and Y test, basically. I don't need the X train and the Y train yet. And I'm going to reshape it. I'm going to reshape it. These are basic preprocessing you need to do before you like feed your data to your model. and we're going to scale it. So these are basically all the processing we need. And what we need again is the URL. So what I'm going to do is that since I'm going to go to the TensorFlow 7. Okay, let me not do that. Let me copy this. Okay, so now I'm going to like explain what this means now. So you have your server running with the model in the backend, get, and now we want to like send a request to get prediction. So now we want to send a request to a specific URL where the model is hosted. So what we do is that we let me do 7.0.0.1. So we're going to is running on a local host. Okay, let me put local host here. Oh, it's still the same thing. Okay, and the port, like we said, is 8501, right? Yeah. So and now the model name is the model name we put in the Docker file, which is image classifier. Let me just copy that. And the verb means like the end point, like what we're actually doing. So we're making a prediction. So we're going to predict. Hope everybody understood that. I hope so. But let me go to their documentation and show you more example what they're doing. Yeah. So you see, to make a request, you need to put your make a post request to this kind of okay, yeah, we're using the predict, yeah, so the predict API. So we're going to make a post request to this URL. The format is like this, and that's what we basically did here: post, ports, version, models, the model name, and the predict tag. Yes. So now let's make a request. So I'm going to import. I'm going to import request is a Python package for making HTTP requests. So what we're going to do is okay, yes. What I need to do now is the data itself. The format for sending data to TensorFlow 7 is like this. So you need to put your data like this. You put the optional is signature name. You don't need to put it, but you need to put the instances where the actual data is. You get. So let me just let me create a function. Then we use the request package, make a post request to this URL, and with the JSON data. So when we do that, we JSON encode it. My colleague should have taken you through all these steps before if you attended the previous type session, but I'm just kind of explaining it for you. Yeah, so and now the prediction is yeah, and we're going to return predictions. So let's make our first So what I'm going to do now is I'm going to take X test and I'm going to like sample out one example. Yeah. So I'm going to take like, don't worry, you will see what it does. And I'm going to print prediction. So let me run the command and see what it outputs. So we are in the right folder. All I just need to do is, hopefully I didn't make any error for now. So what I'm going to do now is write Python predict.py. Oh, sorry. All right. So what happened here is that the response from this TensorFlow 7, look at it. They said the response format of the predict request. Most of the time, it's the documentation that helps really. Yeah. So if you get yourself stuck somewhere, it's better you like check the documentation and you see why something is like this. You get basically. And so this prediction, this response is in this format. So it's going to be a dictionary. So I want to collect the value inside here. So I'm going to have the normal Python dictionary. You access the key basically. Yeah. So they said the key error. It's supposed to be predictions, not prediction. So let me run it again. This is because I don't have a CUDA. I don't have GPU on this virtual machine. So you see that it produced an output. It produced a prediction. And normally, TensorFlow models, their prediction is in decimals. You get. So let us make it like something that we can understand. Yeah, so I'll create a for loop. I'm assuming that we know Python here. We know Python. Yeah. So some of these commands should not be like foreign to us. So don't worry, when it runs, it will be clearer what this is doing. Oh, I need to import. Don't worry, I will explain everything to you guys. Let me just type everything I need to type first. All right, let me run it again. Okay, now look at what happened now. What I did is that I sent it a test value, like a number. I told you that we're working with MNIST dataset. An MNIST dataset is actually an image, a black and white image of number. So somebody wrote down number 9, black and white, number 0, yeah, they're just digits, basically digits. And so what I'm sampling, I'm taking out one example, one training example, X test, and I'm now like looping through it, basically selecting I and pairing it. Enumerate gives you an index and the actual value get. And so what I'm doing is that I'm taking it out of the test. The Y test is the actual Y value, the actual value. And this prediction, this is the predicted value that the model is predicting, this spread. This MP.argmax returns the index of the highest number. I hope people have background in NumPy and pandas. So that was MP.argmax does. It returns the value of the highest, the index of the highest value. Get. So that what argmax means. So that's what I'm basically doing. So this is the true value of it, and this is predicted value. And we can see that, yeah, this TensorFlow 7 model, or this model that is hosted on TensorFlow 7, yeah, we can now send requests to it from anywhere. The things that we're hosting it on our local machine. But imagine if we are like online, we're going to go into using this TensorFlow service on Kubernetes. Kubernetes is a container orchestrator, so it takes care of the pods and the Docker images, everything for us. So we just need to make a YAML file. We'll get into that. So, but we can see that we can actually make predictions by just sending our images to this URL, basically, and we're getting our outputs in this format. Get so that is that for this, like, for this first stage. For this first stage of using TensorFlow service like standalone. So what I'm going to do now, I'm going to like host TensorFlow 7 on Kubernetes. This model and TensorFlow, we're going to host it on Kubernetes, right? So let's get into that. So I'm going to stop this one that is running now. All right. So what I need to do now is, you know, from your material on in the Hamoye labs, that to start a service or a deployment, you have to build a YAML file. So let me just create a folder for the YAML files, kubeconfig. Basically now, what I'm doing now is I'm going to create a YAML file that spins up it spins off pods in a deployment. I'm guessing that you understand what a pod is now and what a deployment is now. Yeah, so a deployment is a group of pods with the same Docker image, in the same configuration, basically. So that's that. Let me build a what do you call it, a sample YAML file for us here. I'm going to call it deployment.yaml, right? So since I have this VS Code, right, I have this Kubernetes extension running. So if I just type something like deployment, going to like pop up all the stuff I need. All right, so let me put in the name. Let me call it TF7. I'll explain what all this means. Classifier. All right, so this tag, what this means is this is going to be the name of the deployment. You get this is the name of the deployment, TF7 classifier. Now we know that a deployment is a group of pods. So how will this deployment know which pod is for it? It's through this tag app TF7 classifier. What this means is that it's going to all the pods that has this name TF7 classifier is going to be under this deployment. Hope you understand what I said. Right. So any app, any pod that has this tag TF7 classifier is going to be under this deployment. Now, what this one means is that, so this is the name of a container. You know that containers run in a pod, basically. So the containers, the pods, the name of the pods will now be TF7 classifier that run this image. Any pod that runs this image is going to be named TF7 classifier. I hope it makes sense. I hope like you understand. You can check out these things on their documentation, Kubernetes documentation. You see what all this thing means. Yeah, so I'm naming the container TF7 classifier, and now we need an image, basically. So what I'm going to do, the standard procedure for this is for you to host your image on Docker Hub. So you build your image locally. Now what you need to do is you load your image on Docker Hub. But what I'm going to do is that I'm going to use the image in my local virtual machine. There's a command that will run. Don't worry, let me you know that TensorFlow 7 model that TensorFlow 7 service, this is the name of the Docker image. The Docker image is on, let me just, Docker images, right? So now there's a Docker image in my local machine called TF7 classifier, basically. So it's going to use that image. And what this container port means is what port is running, what port is accessible for this service. Yeah. So what ports are we using? Remember that when we're exposing ports, we expose our local machine to the ports 850 of the container, 8501. So that's the ports we're using for now. Get. So now let me run this command. Let me run this command. So I'll copy down the command. Let me run it. Oh, standard error. So Kubernetes configuration, they don't use underscore. I always make this mistake. They don't accept underscore, so you have to use dashes in their configuration. All right, so let me run that again. Yeah, so our deployment is up, so we can just do kubectl get ports error image pool. So what this means is that it cannot, remember what I said, that this image is in my local machine, but it's not actually getting the image because I need this kind cluster I'm using. I need to load this image into the kind cluster. Yet I said traditionally we will have posted this image on Docker Hub and we'll pull it from Docker Hub. But I didn't want to do that because it's going to take a lot of time. So let me just run this command now. So it's going to load the image into kind. It will take some time, just a few seconds. Okay, so it's done. So let me get pod now. So it's going to take some time to recognize the image. Let's give it some time. In that sense, let me build a service. Check it again. Yeah, so you can see now it's running, right? So before it was saying error image pool, that it cannot see the image that we want. So I've loaded that image into the kind cluster, and now it is running perfectly. Yeah, so that's that. And now you remember, for every pod, you need a service. So a service is the way that the Kubernetes, that the pods can communicate with the outside world. Yes. So let me create a service file. Let me call it service.yaml. Yeah. Oh, and so since I have this, it's just simple. So the name of our service will be, let me call it TF7 classifier again. Oh. And now a service works for particular pods, right? It works for, like, there's a pod, and now there's a service in front of that pod that helps that accepts traffic to that pod. You get that? That's where we're going to send our um, prediction to. You get, we're going to send it to the service, basically. So now what we're going to do now is the pod that is going to send it to, what's the name? So the name of that pod is actually this TF7 classifier. So I just made the names to be easy. So it's going to be easy for us. And so what is going to be the port for this service? Let's give it port 80. But now you said, what's the target port? So this service is going to send some information, some data to a pod. So what's going to be the port of that pod? And remember that we are working with port 8501. Port 8501. Yes. So now let me build this YAML file. Yeah, so So we can see now it's working. So let me call it kubectl. Let me check get service. Now there's a service called TF7 classifier, right? So now how are we? Okay, now let me now explain something to you guys. Like if I put a type here, what will I put that type? Now, what does this mean? You know, normally in Kubernetes cluster, a cluster IP is an internal service, like an internal IP. It cannot be accessed from the outside world. Then a load balancer is going to get an external IP, so it can be accessed from the outside, from the internet. Get. But let me run this command now. So it's configured. It got the change, and let me get service. So you can see now that this TF7 classifier is a load balancer. Traditionally, a load balancer will have an external IP, right? You're going to have an external IP because it's going to accept out inputs from the outside world. But since this is a local Kubernetes cluster, this is not a Kubernetes cluster like that has internet connection, like, or sorry, that has an external IP, like, let me see a cluster on AWS or a cluster on Azure or Google Cloud, a Kubernetes cluster you get. So it cannot get an external IP, basically. An external IP is kind of, you have to go through a cloud or you have to build up your own Kubernetes cluster and with networking, give it an IP, right? So what I'm going to do now is there's a hack to that. I'm going to just port forward that service. So what this is doing is that it's port forwarding this service, this TF7 classifier, the port 880 on my local machine. To, you know that this service is open on port 80. So I'm port forwarding my local machine port 8080, local host port 8080 to port 80 of this Kubernetes service, right? So now we can see that it's waiting for input. So remember that I made a prediction file. Remember I made a prediction file, a predict.py. But that this predict.py was going to the TF7 classifier. So let me just edit it a little to go to this port 8080. Now, if you see that it's running, right? It's waiting for the. Now I'm making a prediction. Now you see that I said it's handling connection for port 88. That means it accepted input from, so it accepted this data, this input, and it made a prediction for us. So it's basically like TF7 but Kubernetes. So it's kind of helps us to let me answer a question. Why Kubernetes really? Because Kubernetes it does something called auto scaling. It manages so based on the request it gets, it scales up the pods or scales down the pods. It also manages resources for like CPU, GPU, and things like that. So that's why everybody like mostly wants to use Kubernetes to host their model, because it's going to reduce latency. It's going to like scale up fast, scale down, manage your resources for you, and it takes care of almost everything for you. That's why Kubernetes is very, very popular. All right. So I'm done with hosting TF7 on Kubernetes. That's that part. And I hope everybody understood from there. So now I'm going to go to Kserve, right? So let me go to the documentation. So what I'm doing now is I'm installing Kserve standalone. Like from what I said here, I'm installing Kserve standalone. And why I'm doing that is because it's going to be faster. Normally, traditionally, Kubeflow comes with Kserve. It was called KF7 before, but now they've changed to Kserve, right? So it's basically the same thing, but it just like their package is now is now standalone. It can be used alone, and it can also be used in Kubeflow pipeline, basically. So Kserve comes with Kubeflow. Okay, but spinning up a Kubeflow cluster and everything is going to take a lot of time, and it's going to take a lot of memory. And this Kserve is cheaper because you can run this on your local machine, and you can do testing and experimenting and stuff like that. So that's why I stood with this. So everybody can do that on their own. So what you need to do is just install kind. I've installed kind, but let me show you a way to install kind. Yeah, so installation of kind, depending on the operating system you're using. On Windows, there's a package manager called Chocolate. I don't know about it. I use Linux. On Mac OS, you can just do brew install kind, or you can download the kind manual, the binary file manually, and what they call it, and install in your for Linux on Mac and Windows. So based on your specs, you do that. And also kubectl. I hope everybody should have kubectl now, because it's basically the way for you to interact with your Kubernetes cluster. If you don't have kubectl, you can't like work with your Kubernetes cluster. Then we also need Kserve to run this script, and it will help you install all the services you need for Kserve. So that's that. This just an easy. This is the quickest way of getting Kserve on your local PC, and anybody can do that. Yeah. So done with that. And now, so I want to run a test service for us. Like, so we'll see what's actually Kserve. Yeah. So let me run the documentation for us. So I'm going to explain what all this means. So let me clear this. Let me create a new folder called Kserve. Do I have it? No, I don't. Kserve. Right. I don't have it. Okay. So in Kserve, you know that in Kubernetes we had something like deployments, services, gateway, and things and whatnot. So what Kserve does is that you just need one YAML file. You just need one YAML file, and you can spin up whatever you need. So that's why people use Kserve. In Kserve, we just need one YAML file. But using Kubernetes traditionally, we need to have, like, basically, if we followed the right way, we will have needed to make like 4 YAML files. Let me explain. Why I said that is because imagine you have your model in the backend. What a traditional user will do is just send the image like that to your service, right? So you have to run the pre-processing step and the post-processing step. Like, you pre-process your image to the right format for your model. Then what is predicted, you now need to post-process it, like put it in a right format for the user and send to them. If you get what I mean. So that's why if we had done that on Kubernetes, we would have needed like 5 or 6 of this. 6 of it. Deployment for the model, service for the model, deployment for post-processing, service for post-processing, deployment for pre-processing. And you get, so Kserve gives you this easy way. Just need one YAML and you have everything that you need. All right, so let's get to that. So in this test data set, this test trial we're going to do, we're basically going to use a common sklearn model, the iris dataset. I hope everybody here will have known what the iris dataset is. Let me check. Okay, so the iris dataset, it classifies whether the classes are Setosa, Iris Setosa, Iris versicolor, or Iris virginica, and the input data is sepal length, sepal width, petal length, petal width. So the model will now classify, is this particular data, is it actually a setosa flower or versicolor flower, virginica flower? Hope you understand that now. So what I'm going to do, I'm going to run this command and I'm going to explain what they all mean. We hope we know what a namespace is. So what a namespace is, from our own understanding, is that imagine you're working on three projects or three projects, let me say, and this project needs to be separated. Like one pod is not supposed to be messing with the other pod, or they're not supposed to be connected in any way. So what namespaces gives you is that ability of you like separating your different your applications differently. So this application one, namespace application one, does not have anything to do with namespace application two, and get that. So that's what namespace gives you. So let me create a namespace. Yeah, so the namespace has been created. And let me now create a service YAML. Let me not use it here. Let me create here. I'll call it isvc.yaml. Yeah, so let me copy this command. I'll explain what they do shortly. Yeah, so let me go back to my. So now let me explain. So in Kserve, what they use is inference service. Inference service, and it covers everything that we need. You get it spins up the deployment, spins up the service, spins up everything that we need for the application. And so we're going to name this inference service sklearn iOS. So that's what this metadata name means. Kind inference service. Now spec is where the actual prediction and everything goes on. So predictor is we are now telling it what we are building a predictor, something that predicts whether something is where that does the actual prediction basically. Now by telling what model is it sklearn, TensorFlow. So let me Kserve on like TensorFlow 7. You can use as many models as you want. As it's TensorFlow, there's PyTorch, there's scikit-learn, there's XGBoost, there's Spark MLlib, there's LightGBM, MLflow. So Kserve is universal. Yeah, so we're giving the name sklearn, and now where is this model actually stored? Where is this model actually stored? So it's stored, that's where this storage URI is for, storage URI. So this particular test model is stored in a Google storage, in Google Cloud Storage. That's what this GS means. If it's an S3 bucket, is S3. If it's Azure Blob Storage, I've forgotten that. And also there are 4 options: Azure, Google Cloud, AWS, and URI. Like you are hosting that model on a server, so you give a URI. Don't worry, we'll get into that. So what's there? So will save it. After saving it, so I'm going to run this command. Now let me copy this command. kubectl, apply on this namespace kserve test. What's the file? It's going to be kserve isvc.yaml. So it has created it. So now how can we like see whether this service is up? So what we just need to do is run the normal command kubectl get service, and we wait, no, that's not the command. Yeah, so it's get inference service. So it gets inference service. So we can see now that yes, this model is running. See, ready, true. Name of it is sklearn. Yeah, the URL. We'll get into how to access this model now. I'm going to get into that now. So now we have this model. How are we going to make a prediction to this model? So that's where we're going to build a predict file now. We're going to, let's call it predict.py. Now, close to 1 hour now. So let me now show you like how we can make a prediction. Okay, so in Kserve, the methods for making predictions is kind of complicated. So let me explain. You have your this because this stuff is this service is running on our local machine. Because it's running on our local machine, it's localhost 8080, and the domain is example.com. What this means, why is like that is this is running. We don't have a external IP, we don't have a domain, we don't have like a standard Kubernetes cluster. So because this is an experimentation cluster, yet this is how it's going to be. But basic when you are deploying on your own, maybe on cloud, if you have that kind of resource of time, you have to change this IP with IP as of that cloud service, and you have to, if you can, build a domain of your own. Basically, this namespace. So let me change some of this stuff so it works. Okay, so now let me import requests as usual. This is what is the Python package you're going to use to make our requests. So if you look at this call command, I don't know if people are like you know Linux command very well. Call is a normal command used to for downloading, and you can access web pages through from your command with coil. There's coil and there's wget. But in this case, I'm going to use coil. And so let me explain what it does. So this /h means headers, and this is the actual URL. Let me copy that. The URL. The actual URL. Okay, so this is the URL that is going to send the date, though we'll see what the test data is. You need to send the test data to, right? This is the URL. So the ingress host and the ingress port, and this is the version. Like this is how it was in TF7 basically, and I think I've explained what all those means. So now, what are we sending? Let me put in the data now. The data is okay. So this is the data. In TensorFlow 7, you needed to have the instance key and now a list of the values. Remember, I did to list. Now, so what this means, remember when I opened this, remember when I opened, okay. Remember when I opened this here? So this is the sepal length, sepal width, petal length, petal width. There are two examples. So we're going to get two predictions. Yes, we're going to get two predictions from the model. Get so now to make the prediction, we're going to use the requests package as usual, and we're going to make a post request to this URL and with this header and with this JSON data. So remember when I said that in REST APIs we work with JSON. So that's basically it. We're sending a request to this URL with this header. What this header is actually is in the cluster, in the Kubernetes cluster. What pod are we sending it to? So I would like to call it the IP address to the pod, but the IP address or the way of accessing the pod is through these services. Let me explain again. You send to this URL, this ingress like localhost and 80. This is the way to access the Kubernetes cluster. This URL, you are accessing the Kubernetes cluster, right? Now this host is where the model is in the Kubernetes cluster. Which pod is it? So when you send in your data to the cluster, this host will now tell you, okay, this is the pod you are sending this data to, basically. So we're now going to print out, sorry, going to print out the response that we get. So this is how to make a request to your Kserve with Python. We could have done it easily with this command here, but I don't think anybody will understand it. So I just said, let me take my time to explain what all this means with this here, basically with Python. So now what I want to do now is, in Kserve, for you to access your cluster, you're going to make a request to ingress gateway. Remember in your Kubernetes material, they explain to you what an ingress gateway is. Yes. So this ingress gateway is the gateway to your Kubernetes cluster. So this is where we're going to send our what do you call it, our input, our examples to this gateway. So what we need to do now is, because in the previous one I said, because we don't have an external IP. If we had an external IP, it would be something like 120 dots, something. So, and you cannot access that IP from the internet. But since this thing cannot be accessed on the internet, we have to connect our ports to the ports of this Kubernetes cluster, of this gateway. So that's where this port forwarding, we're doing this port forwarding again. Right? Okay. Like I said again, we are doing this port forwarding because we don't have an external IP, because this is a local experimentation cluster. If this was a real cluster in the AWS cloud base, or sorry, a cloud service, I'm saying it, any cloud service, you get an external IP, and then you don't need to port forward. You just send your data straight to the external IP. Hope I'm making sense. So now we port forward. We're port forwarded, and now we just need to run our prediction. Let me SSH to my virtual machine. And yeah, so I'm in my virtual machine. I'm going to cd to tabs. I'm just going to going to cd to Kserve folder, right? That's where the script is, right? And I'm going to activate the hope we understand what conda environment is. Yeah, so then we're going to make Python predict.py. Yeah, so we see now that the prediction is out. So what this did now is, remember, there are three classes. There's Aris Setusa, there's Aris Vesicolo, and there's Aris Vegenica. We sent in this test data, this example, this X data, yeah, and we got out this output. Hope you understand. We got out the prediction, and it's predicted whether this is Setusa, or it predicted that this is Vesicolo. Actually, since this is, Python is zero index, so 0, 1, and 2. So basically this is the sequel. So that's that. So I can stop the post forwarding and okay, yes, I need to stop the, the service because it's going to take some resources. I see. Yeah, all right. Okay. Check why it's saying this now. So let's try again. Oh, sorry. I'm sorry. So what happened is that because yeah, so because it is this we not specify a namespace. When I told you that namespace gives you this ability to separate your projects. So when you run this kind of command, it thinks that it's in the default namespace. Good. But this test we ran was in, remember when we created this namespace and we ran the command on this namespace, this Kserve test namespace here. So what I just need to do is add that namespace tag. Oh, yeah, so you see that it's deleting the service now. Yeah, so most of these confusions can happen as you go, but it's good that you understand. Now, what we're going to do now is we're going to deploy a standard TensorFlow model. Let me explain that. We have been using test. Now, what we're going to do now is a model out there, an exception before model that was trained to classify clothes. Like I think this it was trained on a fashion data set. It can classify trouser, shirts, dress, cap, I think, and whatnot. Those are so now we want to run this service, this TensorFlow model now in Kserve. We want to see how it works. How is it going to do that? So now what I'm going to do, I'm going to download the weights. I created a folder called clothes for this because it's like a clothing data set, like it was trained on clothing data set. And so I have that folder already. So I'm going to download the, the weights. There's downloading the weights. Now I'm going to run Python convert. I'm going to explain why. All right, so let me now show you the convert script. I already have it in place. So what this does is that you see that it imports the TensorFlow as TF library, Keras library, and all. So it's going to load that model because it was the weight that we downloaded. It's not the actual model. It's going to load that model, and now we're going to save it as a save in the save model format. You get. So let me show you the documentation because everything is in documentation. You just have to look at it more. So the TensorFlow, it's not overview. Yeah. So to use TensorFlow's model, yeah, you need it in a TensorFlow saved model. You get. So we need to save it again. We need to save that large model weight that we just downloaded. So I'm going to run this command. Python convert.py. So now it's going to load the model and it's going to save it. Yeah, you're going to save it. And it's going to take some time to save it because it's a large model. Yeah, so as that one is going, okay, we need to wait. We're now going to all right, so this model now, in the ISCV format that we just used. The model was stored in Google Cloud Storage, right? So what we're going to do is, let me see whether it's done. Okay, it's done. So what we're going to do is that instead of hosting it on cloud storage or Google Cloud Storage or whatnot, we're going to host it on my local PC. I wanted everything to be hosted on my local PC so it will be fast to get. So I'm going to run this command. What this command does is that it goes to the clothing model. It converts it to the zip or a tar file. You know, there are different ways of what's it? Is it archiving or be compressing? Yeah, it compresses it and it zips it. So that's what this command do. Yeah. So let me run this command. Hope yeah. So it's zipping it. It's going to take some time and it's done. So now what's going to happen is that I'm going to host this file on my local PC. So Python on its own comes with a module called HTTP server that helps you like spin up a server, just spins up a server for you on your local PC. You just need to run this command. So it's just a handy Python script that helps you start up servers on your local PC. So now there's this server running on my local PC. So let me access it for you. 8,000, right? I'm going to port forward it so it can be accessed for So now if on my browser I go to localhost 8,000, you will see that I can see those, like now these files in my local directory. Now I can download them. Basically I can download them. But let's keep that. Let us now get our TensorFlow 7 YAML file for Kserve. All right, so from the documentation, I'm just going to copy the example file. Yeah, so I'll now edit it for us to see. It's called it TensorFlow.yaml. I'm going to paste this here. So now, what are we going to name this? What are we going to name this service? That's what this is. What are we going to name it? So I think yeah. So I know why. So I'm going to name it clothes, right? It's just you can name it anything you want. You can name it anything you want. It's just like for identifying it. Basically, there's nothing special about it. So I'm going to name it clothes. Now, where is it going to download this saved model from? That's the most important thing. Where is it going to download it? So since we posted it on our local PC, let us I'm going to copy. Yeah, so this is where the file is. So it's going to download it from here, unzip it, and load it into the pod of the Kubernetes cluster. That's what Kserve will do it for us. So that's why Kserve is like it's very easy. It's very like it's faster, it's easier. So what you just need to do is if you want to host it locally or host it on online, you just need to zip it and put in the URL for that file and to download it for us. But for us, Kubernetes will not understand what local host means. So we need to find the IP address of this PC. Okay, so what I'm going to do now is I'm going to type in ifconfig I think on Windows it's IP config. It's just basic IP addressing. So I'm going to copy this IP address. This is the IP address that we need. On maybe on your local machine, you see something like ETH0 or ETH something. Internet is IP address. Let me now go into that. So it's now I'm not going to copy it here. So this Kserve is now going to go to this IP address on this port, download this file, and load it into the pods that we are initializing. Looks like it wants to rain. All right, so we're not done here. We need something else, right? So Kserve doesn't know how to handle your resources for you, your CPU, your memory, your GPU if you do. So you have to specify it for them to understand. Okay, so I'm going to write in, like type in the you can get this on online. I will explain what it does. All right, so I need to put this in, because if I didn't specify this, Kserve will use all the CPU on my PC to manage this to run this pod. So if I want to run another pod, it won't, because there's no sufficient memory for it. So what this command means is specifying resources for us. Like hope you can hear me. The resources is like the resources tag. Now, what this request means that on the build up, like when you spin up the pod, this is the limits it can. This is what it can take. Like when you just start it up, this is what it takes. Then now the limit means how much can it take in the process of this calculation or the processing. Is okay. Now let me just tell you, CPU is called like 0.5 means it's going to take 0.5 CPU, whether it's going to take half of your CPU processing. It's going to take half of your core. That was 0.5 means. Now memory is like 256 megabytes. Is it megabytes? That's, yeah, megabytes. 256 megabytes. Get so that's how much RAM is going to take from it. Now this limit, so the limit it can take during its processing is one CPU, like one CPU. Now one thing, one CPU is kind of confusing, but that one CPU means all of your cores, like all of your CPU, one of your cores. Like it's kind of complicated, but I feel what it means is that taking all your cores, of your CPU processing for this service or for this port. And now the highest memory it can take is 512 megabytes, which is enough for this for this service. So since we are done with the all the configurations that we need for this YAML, what we just need to do is run. Sorry, we just need to do is to apply. Yeah, get clear of this. And since we're in it, we just need to apply. Yeah, so we see that it has created that I service for us. And let me run get, it's inference service. So it's IS, it's just a short way of. Now we see that the service is up. That's spinned up the service for us. And let me go to ports. So I know when I said Kserve helps you spin up the port, the deployment, the services, everything for you. You just need to build one YAML file, and you see that it's easier. It's actually easier, and all this can be run on Kubeflow. But because Kserve comes pre-installed in Kubeflow, but since we're just using it for experimentation and testing, we can just run. We're just using it on kind, basically. Yeah. So we see now that we did not close this. We didn't delete this TF7 classifier. So let me, because it might be taking up some memory. Let me delete that. So it is kubectl. It's think deployment of YAML, and there's also service of YAML. Yeah, so it has deleted those. It's terminating. You see, so it's terminating that the TF7 classifier that we built previously, and you see that our cloud predictor is running. It's running now. Another thing we need to ask ourselves: how are we going to like send in prediction to this model that is hosted here? So let's go to. I prepared a notebook for that. Right? So now, as usual, we import requests, right? So we import requests because requests is what we use to send in our is what we're using to send in our requests to the service, basically. And we now remember what we used the last time. Where is it? For that prediction. If you remember, you see service, namespace, domain is almost exactly the same thing. It's almost the same thing. And so we're just we just changed the name. Service name now is clothes, but here the service name was sklearn iris. So clothes.default was the default namespace. The namespace here was Kserve test. Remember, we didn't specify a namespace in that one. And so the domain was sending to its localhost 8080 and the host here. So let's run this command. Now, remember that we are using a different model. That model predicts is a fashion MNIST data set or fashion data set. Yeah, so it predicts clothes, which what's like class of clothes, something, whether it's trouser, shirts, and whatnot. So because we train it on an exception network. You know, there are different architectures of convolutional neural networks. There's exception, there's inception, there's BGG, there's Google Linet, there are a lot. So we want to run the pre-processing as fast as possible. We just need this. Keras already has this package that helps us run the processing for us. Now it's time for us to send in our prediction. So let me show you what this is. So I'll copy it and paste it for us here. So we see what we're sending to the model. So we're sending the image of a trouser, pants. In America, they call it pants. So this is trouser for us. Yeah, so that's what we're sending. So you see that it has run a processing for us, and it has put it in the accurate shape, a 4x4 tensor. Then to send in a request, we put it in a normal, you know that all the services, they have their standard way of sending requests. So instances x.toList. So this x tensor, we're converting it to a list. If I run it for you guys to see, that it's a list of lists actually. It's long. That's why it's taking this much time. You see it's actually it's a 4x4 tensor. So you can actually understand it, but we know that its images are there basically. And also we send in our requests. Wow. Oh, thank you that now we have gotten an error. What we didn't do again is that we didn't port forward. When I told you that we need to, because this is not a cluster hosted online, we need to port forward. But if it's a cluster that was hosted online, that has an external IP, we just need to put in an external IP and it will send, we need to port forward. But since it's not our cluster, sorry, it's not a cluster on cloud services, so we have to port forward. So let me get to where I round up port forwarding command. Yeah, so this is it. Yeah, so now if we send this request, it shouldn't give us an error. See, it got in something, and now let's put in a response. We got a response. So what is actually this response now? Let us clean it for us to see. Now the classes that was trained on this model, like I said, it was fashion dataset, dress, hats, long sleeve shirts, outerwear, pants, shirts, shoes, shorts, skirts, and t-shirts. So there are 10 classes that was trained in that model. So it's like multi-class classification. And now, so let us see which classification is for which. You know that when I opened that image, it was trouser. So now let's see what it predicts it as. So we see now that the highest score was for pants. So our model accurately predicted that that picture was pants or trouser in our case, we are Nigerians. So yeah, so that's that for the TensorFlow with TensorFlow model with Kserve. I don't know if there's time. I would have loved to go on to this transformer part, but is there time, Christian?
Yeah, we've used up a lot of time, but you can add if it's an extra 15 or 10 minutes. Also, you can do that.
Okay. All right. Okay. So now let me I want to explain something to you guys now. What we did here is an issue with it, basically. The issue with it is that now we require the user to pre-process the image. So the user will have to pre-process it before sending. But in normal use cases, the user just sends in the image. Do you get? So in our case now, there's something wrong somewhere. So the user needs to just send in the image, and the service, the inference service, runs the pre-processing and the post-processing. If you get what I mean. But what we're doing here is we're running it because the user does not know all this. The user should not know it. You just need to send in the image and get out the what class it is in. You get. So that means now in that our service, we need to use something they call a transformer. Now this is another it's also in their documentation what this means. So this transformer component, what it does is it does the pre-processing. If you look at the documentation, see that it's a component that does the pre-processing and the post-processing alongside with the model inference. So you see, so we just need to send to it what the Python script that does the pre-processing. What is we need to do now is create a Python script that does the pre-processing, save it in Docker Hub, and we just download the Docker image into our Kubernetes cluster. Let me explain again. What is our work now? It's what we need to do is build a script that does the pre-processing and post-processing. Put it in a Docker image. I'm not going to do all that because that's going to take a lot of time. But I already have all those prepared for us. So we're going to convert it to a Docker file, push it to Docker Hub. So we need to have a Docker Hub account, and I hope if you all have a Docker Hub account, or if you do. So now the Kserve inference service pulls that Docker image from Docker Hub. It pulls it from Docker Hub and puts it into the Kubernetes cluster report. So I'm going to give you like the overview of how to do that. So now we need to create a Python script. I already have the Python script created. Yeah. So let me show you how the Python script. It's going to be somewhat confusing to non-Pythonistas. Yes. So all right. So let's get into this. I'm assuming that we know object-oriented programming here. Yeah. So what this does is that we need to build this class image transformer, right? And it inherits from another class called Kserve model. It's kind of hard. I won't go into what's that Kserve model, but we know what inheritance is from our object-oriented programming. And so we put in a preprocessor. This is attributes. These are attributes now of this image transformer class. These are attributes. The preprocessor we're using and the classes. So now the actual methods that are going to be run are the the preprocess and the postprocess methods. These are the two methods that are needed in this class. So the preprocess, it's kind of runs the preprocessing for us. It does some preprocessing from this method. Remember what we did in the last one? We process from the URL and we return a list. And so this preprocessing, it calls this method, and hope you understand. And it iterates through the inputs that it gets and preprocesses it. And now this post process, it collects after the model has done the inferencing, it collects the data, and it now does the post processing where we remember when we did this dictionary stuff, where we put this, we zipped the classes and their prediction to a dictionary. So that's what it's doing here. It's doing a post processing for us, put it in a neat way that we all can understand. And so these are the requirements for the transformer model. If you want like a full on like explanation, it takes some time, which we might not have now yet. So yeah, so that transformer model, now we're going to put it into a Docker file. We have built a Docker file before, right? So we're going to put it in a Docker file. I'm hoping that we understand the configuration of the Docker file. Then what we do, because in that mode, where is the model? I can just close it. Let me- Don't worry. So you know that we needed two packages, the Keras image helper and Kserve SDK. Yeah. So we need to install that in our Docker hub, in a Docker image or a Docker container. You get, because you know Docker containers are just plain; they don't have anything inside. So what we did first, we install Python, we run pipem, we install pipem. Pipem is a virtual environment manager. So we create a working directory app. We copy the pip files. We install the packages we need. So in pip file, these packages here, the Kserve and Keras image helper. Those are the two packages we need. It installs it into the Docker file, and it copies the model that does the actual preprocessing and calls the model Python model.py. This is a fast explanation because it's you need like just look at the documentation, read through it. Since I've given you the background of this is not going to it's not going to be hard for you to understand, basically. So what I did was that I built the Docker image, and I pushed it to Docker Hub. So on Docker Hub in my account, there's a repo, or there's a repository called image transformer that does the transforming for us. So now it's online. What we now need to do is work on our YAML file. Right? And there's there's a there's another thing we need to import. Let me go to the docs and show you guys. So now you see that there's now something they call transformer. There's now something they call transformer that we now need to import. So what it does now is we're now importing the script that does the transforming for us. So it does the pre-processing and post-processing for us. We just need it's in case of it's just simple. We don't need to write YAML files for the pre-processing and post-processing like we have done in Kubernetes. Kserve, we just host our Python script online in a Docker file and we just import it. So it's going to take in a container. So the image is going to be the image we push to Docker Hub, right? And we're going to name it, let's call it image. Okay, wait, let me just call it classifier container. Oh, sorry, transform container. You get? So that's that. Since we have hosted this image on Docker Hub and we are importing it into a configuration file, we just need to run this apply command. So I'll cd to the folder where the Docker file is. Then, sorry, the YAML file is, and just run it. Yeah, so now if you run kubectl get port again, do that. Now you see that it's now something they call a closed transformer. Okay, so there are now two ports, the predictor and the transformer, that will do the transforming for us. Yeah, so we get port again. So both of them are running complete ready. And what we just need to do now is just send in an image, basically. So this is the last part of this. I'm just going to create a predict.py again for this one. So it's just going to be a simple and we're just going to collect this. Let's collect this. And since that's the URL, it contains everything that we need. And I'm just going to collect the actual URL. Yeah, so remember, this is where the image that we're working with is, right? So what we now need to do is just make the request. I'm just going to collect everything that we need from here. Print the response. Yeah, so that's it. So if you just run this script, it should work. But first, let me once again put forward. Remember, we're not working on a cloud-based PC. We're working on our local PC. So if I let this up and see it around Python predict by. Yeah, so you see now that we just sent it the image. Now that what the user will do, just send in the image to the app or to the deployment, the model, to the app that is running online. And what you just need is what is the classification? What is it actually? So we can see here that it has pre-processed it and it has post-processed it for us. So now the classification in the same pant is the highest the probability, and so the that's predicted at this pants. So that's basically that of TF7 and Kserve on Kubernetes and Kubeflow. So the thing is, all these commands, this Kserve you can run it on your Kubeflow Kubeflow cluster. You just need to spin up a notebook, and you can run commands on Jupyter Lab. Yeah, so it will have been easier there. Yeah, basically, just you don't need to install kind of anything. Just on your Kubeflow cluster, is run all the commands with your YAML file and to do all the stuff for us. So that's it basically. I'm done. Are there any questions?
Okay, thank you very much, Mr. Hakim. That was an interesting session. I'm guessing there are lots of questions. So if you have a question, you know the drill, just signify by raising your hand, use the hand emoji, and we'll answer the question. Okay, there's already one in the chat. Let me just read it out. It said from David saying, are all these commands applicable on Windows machine?
Yes. You have keep on Windows machine. It's kubectl. You just install kubectl on your Windows and you'll be able to run this command on your Windows.
Okay. Any other question? Okay. Okay, well, in the absence of no further questions, thank you very much, Mr. Hakim. It goes to show that you did a very good job. So I'm guessing you understood everything clearly and fine. Thank you very much for that. For this was beneficial to the data engineering track. Also, on
David,
Friday, David has a question. Yeah, it's a question I already
okay.
read to.
He raised his hand.
Okay. David, you can ask a question.
Yeah, thank you very much. It's not really a question per se. I am in the data science track, and I must confess, this was very, very exhausting. I really need to go back and rewatch the video again and again to be able to follow along. I really appreciate that. I was following. Thank you very much.
You're welcome. Thank you.
Okay, thank you very much for that. I'll have to say again, we have another session coming up on Friday. That will be on neural networks, computer vision. So this will be beneficial also to the data science track. So David, I'm guessing you benefit from that. So thank you very much, everyone, for joining. Thank you once again for hacking.
Thank you.
That's what I have to say. Again on Friday. Okay, stage this is still on, yeah. Do wait to follow up on the materials, do your further research, whatever question you have, you can always drop it on the Slack channel. We'll be happy to help and answer you. This was a very interesting session. Like I said, now we're holding on Friday. This week, that will be on the 16th, I guess. Yeah. So thank you very much. Reaching from Port Harcourt, Nigeria, Christian Ajula, scientist and assistant program coordinator at Hamoye. See you again next time. Thank you very much for this wonderful session.
Thank you.
Have a lovely day.